So this is officially the third part of factors of polynomials. So given that this is a bit more complicated than the one we previously looked at, so given that x cubed minus 6x squared plus 2 equals x minus 3 times x plus 1 times qx plus ax plus b, where qx is a polynomial, I'll explain what it was. Find the value of a and b. So the a and b are there. So first of all, this sum is practically easy because the values of x that make this equation equal to 0, the factors x, the x factors, the x factor, not the x factor, the factors which are x are already, see, they're very clearly over here because you already got x minus 3 equals 0 and x plus 1 equals 0. So if I substitute x equals 3 or x equals negative 1, this entire part, this entire substituent of it will be wiped out. So x equals 3, 3 minus 3 is 0. So because this is 0, 0 times this, 0, 0 times this, 0. This part is totally wiped out, making our equation much simpler. So we can just concentrate on ax plus b. That's exactly what we're going to try to do. We're going to try to wipe out this entire part, x minus 3 times x plus 1 times qx. We want to wipe this out so we can only concentrate on this part, ax plus b equals to that function, because that's exactly what I'm looking for. So now folks, let's try to get started. Let's substitute x equals 3 first, because that's from there, and x plus 1 from there. So substituting, so from this side, 27 minus 24 plus 2 equals 0 completely, and 3a plus b. So that's a 3a plus b equals 5. And this side, 1 minus 6 is negative. So negative 1 minus 6 is negative 7. Negative 7 plus 2 is negative 5 equals negative 4 times 0. So 0, basically 0 this side. And then a negative a plus b. So now we have negative a plus b equals negative 5, and 3a plus b equals 5. So that's equation number 1, equation number 2. So let's do simultaneous equations to find out what it is. Plus b equals negative 5. So now just let's try the subtraction method to subtract it. So that's 2a equals 10, a equals 5, substitute negative 5 plus b equals negative 5, b equals negative 5 plus 5, b equals 0, is, okay, so negative 5, and we substitute inside here, a equals, so a plus b equals negative 5, a plus b equals negative 5, so that's a 4a, 4a equals 10, so that will make blah 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 blah. Let's try that again. That's 3a plus b equals negative 25, and negative a plus b equals negative 5. Sorry folks, that's 3a plus b equals negative 5. Clearly that did not work, it was negative 5. I'm going to try this value. Negative a plus b equals negative 5. So it's minus both sides, so 4a is basically negative 20, a equals negative 5, 5 plus b equals negative 5, b equals negative 10. So a equals negative 5, b equals negative 10. So there we go folks, that's one part of factors of polynomials. So this is the next part. I keep saying next part. This is one part of factors of polynomials. This is when you are given a huge equation, a huge polynomial, and you're given saying that yes, this function is a factor of this. And they want us to find the values of a and b, and hence find out the broken value of this. So that will be like x to the power of 4 plus 6x cubed plus 2ax squared plus bx minus 3a equals x squared plus 2x minus 3 times qx. That's the function we're looking for, qx. And where this is a quadratic factor. So let's go ahead, folks, by breaking this down first. X squared plus 2x minus 3. X squared plus 2x minus 3 is x plus 3, x minus 1. And then, so we get the values x equals -3 and 1. So first of all, we have to substitute it inside the original equation. That will be like -3, so that will be -3 to the power of 4 plus 6, -3 to the power of 3 plus 2a, -3 to the power of 2 plus b, -3 minus 3a. Okay, so we're assuming equals to 0 because we're assuming -3 is actually a factor. Now we have a scientific calculator, which I'm about to use, and yeah, -3 to the power of 4 plus 6 times -3 to the power of 3 plus, yeah, let's just get that first. Let's get 81 plus 18a minus 3b minus 3a equals 0. 15a minus 3b equals 81. And now let's get x equals 1. So that will be like 1 plus 6 plus 2a plus b minus 3a equals 0. Negative a plus b, -7. So b equals -7 plus a. Let's substitute it inside here. 15a minus 3. Yeah, you're still watching. Minus 3 minus 7 plus a equals 81. So 15a plus 21 minus 3a equals 81. So that will be 12a equals 61. Is it supposed to be 61? I don't have a feeling that there's a mistake somewhere. Sorry. 60. Sorry, 12a equals 60. 81 minus 21 is equal to 60. So a equals 5. Substitute back inside here. -7 plus 5 equals -2. So basically, a equals 5 and b equals -2. Okay, so we got that. Now let's substitute it back inside here. So that would mean that it's x to the power of 4 plus 6x cubed plus 10x squared minus 2b plus 10x squared minus 2x minus 15. Okay, and that would exactly mean, let's try division. You have to divide this by its factor. So that would be x to the power of 4 plus 6x cubed plus 10x squared minus 2x minus 15. And we will divide that by x squared plus 2x minus 3. So that will be x squared, so that will be x to the power of 4 plus 2x cubed minus 3x squared. 4x cube plus 13x squared minus 2x minus 15. And then 4x plus 4x cubed plus 8x squared minus 12x, 5x squared plus 10x minus 15. Yeah, I wrote down what I'm going to do over here, and since the board is going off, and 5x squared, since we're substituting, plus 5 squared plus 10x minus 15, that will give us a 0. So that's officially the factor of this. So qx is officially x squared plus 4x plus 5. Now let's clear up some space on top, and let me give you the final answer. So that is basically x to the power of 4 plus 6x cubed. And yeah, where did I write the one where I finished substituting it? 6x cubed plus 10x squared minus 2x minus 15 is equal to x squared plus 2x minus 3 times x squared plus 4x plus 5. So that's basically x plus 3, x minus 1 equals x plus x plus 5, x minus 1. Or let's just say x squared plus 4x plus 5. Thank you, folks. That is basically the end of factors of polynomials. We've basically learned everything from what a polynomial is to basically solving this hard sum. So thank you.